Section 7.3 Estimating a population standard deviation or variance. These sessions, we need to know how to construct a confidence interval for population standard deviation or population variance. And we'll be using a new distribution. We call this as the chi-square distribution. Okay, construct confidence interval for standard deviation or variance based on the chi-square distribution. And this is called chi-square. You're gonna see this is the notation for the chi-square. Okay. And chi-square distribution are not symmetric, not like the z distribution or the t distribution. Okay, chi-square distribution is not symmetric, they are skewed to the right. Okay, means white tails are longer. Okay, white tails is longer, unlike the normal distribution or student t distribution. And also the chi-square statistics are always greater than 0 or equal to 0. Okay, you could see they're starting with the 0, 1, 2, 3, and then up on here. Okay, they're never negative. Again, normal distribution, student t distribution, they have a positive number and negative numbers. But for the chi-square distribution, it's always positive. And just like the student t distribution, we have the degree of freedom. Okay, degree of freedom is going to be equal to n minus 1. Okay, so if we want to increase the degree of freedom, we need to increase the sample size. And for these sessions, we may want to use the table to find the critical values. And the chi-square distribution, we call this as table A4. And table A4, the chi-square distribution, will be used the cumulative area from the right, okay, just like this picture. When we're looking for the table, we always finding the area from the right to the left. Okay, for the degree of freedom, for example, if you only have the degree of freedom is 1, the pictures is going to be looks like the blue line like here. If you increase the sample size, now you do have a 5 degree of freedom, then you're gonna see there's a red line just like this, skewed to the right. If you increase to 10 degree of freedom, and then when you increase to 20 the degree of freedom. If you can increase the sample size, the distributions is gonna be looks like the normal distribution. Okay, looks like the normal distribution. For these sessions, we'll be using the table A4 to find the critical values. You also can use the calculator to find the critical values, but that will be on another video. First, we'll be using this table. You're gonna see this is the chi-square distribution, okay? Chi-square distribution. We call this as a table A4. And then on the left-hand side, that will be the degree of freedom. Okay, degree of freedom will be n minus 1. And on the top, that's a 2 rectangle here. This is talking about the area cumulative from the right to the left. Okay, and then the 3-digit number here, this is represent the critical values. So let's try the first example. Find the critical values for a 95% confidence interval using the chi-square distribution with the sample size of 11. So first, we know n is equal to 11. What is the degree of freedom? That will be n minus 1, right? So degree of freedom is going to be equal to 10. And we are working on the chi-square distribution. Make sure you remember chi-square distribution is going to be skewed to the right, okay? White tail is longer. And then they will have the 95 confidence level. So 95% will be in the middle here, okay, 0.95. And we assume that the 95% areas in the middle, so they should have the same area for the left tail and the right tail. Okay, my graph doesn't do a good job here. You have to remember that area of the left tail will be equal to the area of the right tail. And first part, we need to figure out what is the area for each tail. So remember the total area under the curve is 1. So we could do 1 minus 0.95. Okay, total area, take out in the middle part, and then divided by 2. So each tail of the area will be 0.025. Okay, 0.025. And for these sessions, when we look for the critical values, you could see the S in here. Means like we do have a 2 critical values. Okay, we have the critical values chi-squared to the left, because this is on your left hand side. And this is a chi-squared to the right. Okay, chi-squared to the right. So we do have a 2 critical values. Now, look at the table A4. So we have the degree of freedom equal to 10. So look for the degree of freedom here. 10 will be here. Okay, and then let's find the critical values, the chi-squared to the right first. So chi-squared to the right, the cumulative area from the right to the left, this part will be 0.025. So 0.025, you're going to look at here. Okay, area to the right of the critical value, 0.025. And then look at the degree of freedom. So you have a chi-squared to the right, 20.483. Okay, so this is how you guys finding the critical values to the right. Now, we need to find the chi-squared to the left. Okay, so chi-squared to the left, we already figured out the area from the left is 0.025. Now you need to find out area from the right. Okay, every time when you guys using the table, you need to find the area to the right. So you could do 1 minus 0.025. Okay, 1 total area, take out the area of the left tail, that will be 0.975. Okay, look at the table A4. 0.975 is going to be here. 0.975 to the degree of freedom. So that will be 3.247. So that will be chi-squared to the left. Okay, let me write it down in here. So this is how you guys finding the critical values using the table A4. And this is the procedure to construct the confidence interval for standard deviation or the variance. So first, verify the requirement, simple random sample. And population must have normally distributed. We don't care about the sample size. Even though sample size greater than 30, we still ask for the population must be normally distributed. Then, finding the degree of freedom. These are using the technology, means your calculator, or the table A4 to find the critical values. You do have a 2 critical values, chi-squared to the left, chi-squared to the right. And to find the confidence interval, you just need to plug in your numbers into this formula. And look at here, this is a population variance. Okay, if you're working on the population variance, you just need to plug in on this formula. But if you're working on the population standard deviation, then you need to take the square root for both sides. And then at the end, make sure you draw the conclusion. Okay, let's try this one. Construct a 99% confidence interval for the population standard deviation if a sample size is 23, has a standard deviation equal to 12. So again, we have n equal to 23. So what is the degree of freedom? That would be n minus 1, right? So that's going to be 22. And then we have the picture skewed to the right. Figure out what is the area for each tail. Okay, in the middle, that will be 99%, so that's upon 99. Find out the area of each tail. So we're gonna do 1 minus 0.99 and divided by 2. So that will be 0.005 here. Okay, look at the table. Look at the table A4. Try to figure out what is the critical value to the right and also to the left. Okay, degree of freedom, that's a 22. And then let's find the chi-square to the right. So that's a 0.005. It's going to be here. So critical value will be 42.796. 42.796. And then chi-square to the left. So figure out what is the total area cumulative from the right. You could add up these two numbers, or you could do 1 minus 0.005. That will be 0.995. Okay, 0.995 is going to be here. So what is the critical values to the left? That will be 8.643. That's a chi-square to the left. Okay, after you figure out the critical values, the step 1, now we're gonna find out the confidence interval. With the question one more time, we want to construct a confidence interval for population standard deviation. Okay, we are working on the standard deviation. So we're using this formula. Okay, plug in all these numbers. And make sure this is a chi-square to the right. This is notation. Don't take square with this number. Okay, just plug in here. Chi-square to the right will be on your left hand side. Chi-square to the left, that will be on your right hand side. Okay, because this is an inequalities and then we do the fraction. So make sure you switch these two guys. Okay, chi-square to the right on the left. Chi-square to the left is going to be on your right. Okay, use the calculator. You're going to get this. If we are working on the population variance, we could just stop in here. But now we are working on the population standard deviation. Okay, so we're gonna take the square root for both sides. So this is gonna be the confidence interval for population standard deviation. And then last step, you need to draw the conclusion. Okay, we have 99% confident that the limit of these two numbers contain the true value of the standard deviation. Example 3. I want you guys try to do it by yourself. Figure out what is the sample size, the degree of freedom, and use the table to find the critical values. And then read the question carefully and might construct the confidence interval for population standard deviation or the population variance. Use the formula and then at the end try to draw the conclusion. Okay, so sample size n will be equal to 22. So the degree of freedom will be n minus 1, which is going to be 21. Then use the table A4 to find the critical values. So you should find the area to the right should be 0.05, right? 0.05 and a degree of freedom 21. You should get this guy. And then chi-square to the left, the area cumulative from the right should be 0.95. Okay, 0.95 and the degree of freedom is 21. So you should get 11.591. Okay, construct the confidence interval. Plug in the numbers into the formula. Okay, check your work. Since we are working on the population variance, so we're gonna stop at here. If we are working on the standard deviation, you need to take the square root for both sides. And then now we're gonna draw the conclusion.